All right, we are going to pick up with graphing quadratic equations in standard form, and we are going to be looking at axis of symmetry, vertexes, minimum and maximum, y-intercepts, and of course, how to graph them. If you remember the last time we talked for 8.4, we did standard form as well, but we did it with a t-table, and you were given 5 values of x. You just had to plug in and get the values of y, and you were able to go. Well, now we're going to take this in a step further, and we're not going to give you the 5 values. You got to kind of find those. So we're going to start off. Standard form, remember, is y equals ax squared plus bx plus c. That is standard form of a quadratic. Now, when we look at standard form, the key is what is a, what is b, and what is c. We will be using those letters in different forms throughout this process. Now, what we're going to be starting with is these are the steps listed in order of what you should be doing in order to get the graph and to answer the questions that are going to be assessed and also on the homework and things of that sort. So we start off with graphing a quadratic in standard form. The first thing we do is we are going to find the axis of symmetry. Now, remember back when we talked about quadratics. So if I gave you a quadratic, it looks like this, right? We have a couple things that we need to review. This point here, that is called our vertex. Now, through the vertex, this is our line of symmetry or our axis of symmetry. Okay? Now, as it being a vertical line, remember every vertical line is x equals some number. Okay, so the axis of symmetry will be an equation of a vertical line that goes through the vertex, and it will be x equals some number. Now, the way that you find that is you use this formula right here. You take x equals negative b divided by 2a. So what you're going to do is take the b value, make it its opposite sign. So if it was a positive 4, it becomes a negative. If it was a negative 5, it becomes a positive 5. Then you're going to take 2 times the a value, and then you're going to take those two and divide them. And that will give you the axis of symmetry. The next thing you're going to do is then you're going to find where the vertex. Now notice the vertex is on the axis of symmetry. So when we go to do the vertex, this answer that you get, that is what the x value is going to be on that vertex. So to find the y value, you simply plug the x value in to the original equation, and then you just solve it to find the y value of the vertex. The vertex has to be on that axis of symmetry, because remember, when we talk symmetrical, those two lines or those two sides of the parabola have to match up if we fold it along that line, and that's where the vertex has to be. My next thing I'm going to do is I'm going to find 4 additional points in order to graph it. Now, when we go to graph it, here's the thing we have to remember. If I find these 2 points, let's say, right? I'm going to pick 2 points, plug them in, get the y values. Remember that those 2 points reflect over that line of symmetry and match up on the other side as well. So what you're simply going to do is you are going to pick 2 x values that are either bigger or smaller than the x. Do not pick one from each side. Pick either 2 bigger ones or 2 smaller ones. You also will want to pick x values that are close to the vertex unless a is a fraction. Then you kind of have to be careful with the ones you pick. Then simply plug those x values in, work them out, get the y values, and then just simply reflect them over. Now, when you are done with step 3, this is where you should be looking at a graph of your quadratic. Okay, so when you're done with 1, 2, and 3, you should be able to graph it. The rest of this is just some extra things that we look at. The next thing we do is we determine whether the vertex will be a maximum or minimum. Now, remember, we're talking about the vertex and we're talking about maximum or minimums. Remember, maximum is the highest point on the graph. Minimum is the lowest. So we're looking at the vertex and saying, are you the highest point or the lowest point? Now, remember, if A is negative, then what that does is that causes that parabola to flip upside down. And in that case, it becomes a maximum because it's the highest point on that graph. If A is positive, it causes you to have the normal parabola. And in that case, the vertex would be the minimum because that is at the bottom. That is the lowest point on the graph. Okay? Then the last thing you do is you find the y-intercept. Now, remember, every single y-intercept has to be of the ordered pair 0, comma something. Okay? Now, when you do that, if we take the x of 0 and we simply plug that into the x in the original equation, and then we simply solve it for y, and that will be our y-intercept. Okay? So that is how we're going to do this process. So we're going to start off, we're going to try a few where all we're going to do is find the axis of symmetry and the vertex. Now, what I always like to start off with is tell me what is A, what is B, and what is C. So remember, A is in front of the x squared, so that would be a 1. B is in front of the x, that would be a 4. And C is your constant, that would be a 1. Now, for your axis of symmetry, what you simply do, remember the formula, x equals negative of b over 2a. So b is a 4, a is a 1. So when we do that math, negative 4 divided by 2, that's going to get me negative 2. So my axis of symmetry is x equals negative 2. Next, we're going to find the vertex. Okay, to find the vertex, remember this x value becomes the x of our vertex. Then what we simply do is we take that negative 2 and we plug it in. So it should look like this. It should say y equals negative 2 squared plus 4 times negative 2 plus 1. And then what you're simply going to do is you're going to work that out. So when you look at this, you have negative 2 squared. That's going to give me positive 4. Negative 2 times 4 is a negative 8. And then we have a plus 1, which is going to give us a negative 3. So my vertex would be at negative 2, negative 3 on that one. Okay, let's try this one. If we look here to start, we have A is negative 1, B is negative 8, C is negative 20. Okay, now when we go in here, we want to start with the axis of symmetry. So when we do that, we have x equals negative of b over 2 times a. B is a negative 8, a is a negative 1. So negative of a negative 8 turns it positive. 2 times negative 1 is a negative 2. And we get an axis of symmetry, x equals negative 4. So then to find the vertex, we come in here and we say, okay, I'm at negative 4 comma something. So now I take that negative 4 and I plug it into my equation. So I say y equals negative of negative 4 squared minus 8 times negative 4 minus 20. And so we start to work that out. Negative 4 squared, 16, but it's got the negative in front, so that'll make it negative 16. Negative 8 times negative 4 is a positive 32. And then you have the negative 20. And so then when we add all that up, we end up with a negative 4. Okay? All right, let's try a couple more here. So we're going to start off. Let's label our A, B, and C. So A is 2, B is a negative 12, C is 16. So we start with our axis of symmetry. So we go x equals negative of b over 2 times a. So b here is a negative 12, a is 2. So we end up with negative of negative 12 is 12. 2 times 2 is 4. So we end up with a 3. So my axis of symmetry would be x equals 3. Okay, then we take, and we're going to take that, and we are going to find the vertex now. And remember, that is the x value of my vertex. That just comes right down. Then we take that 3 and we plug it in. So y equals 2 times 3 squared minus 12 times 3 plus 16. So 3 squared, that's 9, times 2, that's 18. Negative 12 times 3 is negative 36, and that's plus 16. So that would get me a negative 2. So my vertex would be at 3, negative 2. All right, let's try this last one. You'll notice here we have a fraction going on. Doesn't really change what we do. It just makes the math a little trickier. You just got to be a little careful. So A would be negative 1/2. B would be a negative 2. C would be 1. So we come in, axis of symmetry. And when you look at that, we have x equals negative of b over 2 times a. B here is a negative 2. A is a negative 1/2. Negative of negative 2 is a positive 2. Half of 2 is 1, but it would be a negative 1, which will get me a negative 2. So my axis of symmetry is x equals negative 2. My vertex then is going to be at negative 2. Remember, that's my x. And then I take that x value, plug it in. So I get y equals negative 1/2 times negative 2 squared minus 2 times negative 2 plus 1. So negative 2 squared is 4. Negative 1/2 of that is negative 2. Negative 2 times negative 2 is positive 4 plus 1. And that's going to get us a value of 3. So we get negative 2, 3 for our vertex. All right, so on those problems, you're just being asked to do 2 of the things. So now what we're going to do is we're going to move forward now, and now we're going to ask you to do it all. So we're going to do all of the pieces, plus we're going to graph it, and we're going to answer the last couple questions as well. Okay, so we're going to start in. Let's start in with A, B, and C. So we got A here, we've got B here, we've got C here. My axis of symmetry, x equals, and we're going to go negative of B over 2 times A. Here, A is 1, B is 4. So negative 4 over 2, which is negative 2. Now, what that means for me is when I go to my graph, I have this imaginary line that is going through x equals 2. Now, somewhere on that line, I know my vertex has to be there. So now I'm going to take, and I'm saying, okay, my vertex is negative 2, and I'm going to plug negative 2 in. So I start in negative 2 squared, that's 4. 4 times negative 2 is negative 8, so that's a negative 4, plus 1 would be a negative 3. So I come over here, negative 2, 1, 2, 3. There's my vertex. Now, once I have my vertex, my next thing is I want to come in here and I want to figure out what are some other points I could do. Okay, so I'm going to come in here and I'm going to go back to my t-tables. Now, I look at the x value in the vertex. It's a negative 2. So I want to go negative 1, 0, or I could also go negative 3, negative 4. Then what I'm simply going to do is plug those values in. So negative 1 squared is 1. 4 times negative 1 is negative 4. So that would get me a negative 3, plus 1 would be a negative 2. So if I come over here to my graph, I'm going to plot a point at negative 1, negative 2. Okay, then I come back again. And now I plug in 0. Well, 0 squared is 0, plus 4 times 0 is 0, plus 1. So now I come over here to the graph, 0, up 1. We take those, reflect them, and we take and we copy those, and there is our graph. Now we're going to ask a couple last questions about this. Next, I'm going to ask, is the vertex a minimum or a maximum? Well, it's at the bottom, so it is a minimum. Okay, the y-intercept, remember this is where we plug 0 in for the x. So if I plug 0 in, we get back a 1, so my y-intercept would be 1. And that's how we do that process. Okay, let's try this next one here. So we're going to start in again. We have an A over here, B here, C here. Axis of symmetry, so x equals, and remember we're going to go negative of b over 2 times a. So b here is a negative 8, a is a negative 1, so that would be 8 over negative 2, which is negative 4. So my vertex will be at negative 4 something. So I'm going to come over here, 1, 2, 3, 4. I have a line of symmetry going right through there. Okay, so now we just got to find the vertex. I plug in the negative 4 on this, and I get back, after I do all the math, I get back negative 4. So I'm going to come over 1, 2, 3, 4, 1, 2, 3, 4. So there is my vertex. I'm going to make that in a different color so it's easier to see for you. Then I come back now, and now I need to figure out some points. So what I'm going to do here is my t-table. Here's my x, here's my y. I personally like to deal with smaller numbers. So if I've got negative 4, I'm probably going to do negative 3, negative 2. And by smaller, I mean just a numerical number, 3, 2. They're right next to the vertex, so negative 3, negative 2. Then what I'm going to do is I'm simply going to plug those in. So I start in and I say, okay, negative 3 squared, that's 9. Negative of that's negative 9. And then negative 8 times negative 3 is positive 24. So I have negative 9 plus a positive 24 is a positive 15 minus 20, and that would get me a negative 5. My second point I'm going to plug is negative 2. So I'm going to plug that in. Negative 2 squared is 4. Negative of that is negative 4. Negative 8 times negative 2 is a positive 16. So negative 4 plus 16 is a negative 12. A positive 12, and then add to it a negative 20, and you're going to get a negative 8. So now we come over here, and we're going to plot negative 3, 1, 2, 3, 1, 2, 3, 4, 5, and then negative 2, negative 8. We're going to reflect those over, and there's our graph. Now we take a look at this one, and we're going to answer these last little questions. Look at the vertex, it's there. This time it would be a maximum because it's the highest point on the graph. Our y-intercept we do not have, so I'm going to plug that in, and I plug in 0 into all the x's, and I am left with a negative 20. So the y-intercept would be at 0, negative 20. Okay, so let's try this third one here. So once again, we're going to start off. Here's my A, here's my B, here's my C. So my axis of symmetry is x equals negative of B over 2 times A. So we have 2 and we have a negative 12. Negative of negative 12 is 12. 2 times 2 is 4. So we end up with 3. Okay, so we have our vertex here is going to be at 3 something. I come over to my graph, 1, 2, 3. I have my line of symmetry. Okay, and now I plug that value in. So I have 3 squared is 9, times 2 is 18, minus 12 times 3 is 36. So that's a negative 18 plus 16, and I get a negative 2. So 3, 1, 2. And let me change colors here just so you see, easier to see for you. So there's my vertex. Now we need to find 2 additional points. This time I'm going to go to the left because those are the smaller numbers. So I'm going to do 2 and 1. So if I plug 2 in, 2 squared is 4, times 2 is 8. 12 times 2 is 24, so that'd give me a negative 16 plus 16. That's going to come out 0. And then if I plug 1 in, I get 1 squared is 1 times 2 is 2. minus 12, so that's a negative 10, plus 16, that's a positive 6. So now I come back over here, I graph those, I go 2, 0, I go 1, 6, 1, 2, 3, 4, 5, 6. I reflect them over, and you'll notice we are stretching our parabola this time. And hopefully you recognize what is causing that is this A value being something other than a 1. Now, we still need to answer those last two questions. And we look at that vertex. Would that be a maximum or a minimum? Meaning, is it the highest point of the graph or the lowest? Hopefully you recognize it is a minimum because it is at the bottom. And in the y-intercept, we don't have, so I'm going to plug 0 in, 0 for the x's, and I am left with a positive 16. Hopefully you're noticing that my y-intercept is going to be that C value. Okay, and the last one we have here, we're going to start in, we take a look, here's my A, here's my B, here's my C. So x equals negative of my B over 2 times my A. My B is negative 2, my A is negative 1/2. So negative of negative 2 is 2. Negative half of 2 would be negative 1. So my axis of symmetry would be at negative 2. So my vertex, I'm going to come over 1, 2. There's my axis of symmetry. Now I plug in my points over here. So I say negative 2, I plug that in. I work that out. So negative 2 squared is 4. Negative half of that is negative 2. And then negative 2 times negative 2 is 4. So that would get me a 2 plus the 1. That's going to get me a 3. So 1, 2, 1, 2, 3. So that's where my vertex is going to be at 2, 3. And now we go to find two extra points. We have our x, we have our y. I'm going to go with negative 1 and 0. So if I plug negative 1 in, oh, sorry, nope, I'm not. I apologize. I'm going to do 0, but I'm actually going to do 2. Now, you might be asking, why am I changing it up? Well, because it's a half. Since it's a half there for the A, I'm going to pick values that when I plug in are going to be divisible by 2. So when I plug a 0 in, I'm left with a 1. When I plug a 2 in, that's going to get me 4. Negative a half of 4 is negative 2. And then negative 2 times 2 would be negative 4. Add it to the negative 2, that's negative 6. Plus the 1, that's going to be a negative 5. So now I come over here, 0, 1. And then I have 2, 1, 2, 3, 4, 5. I'm going to reflect it. And I'm going to reflect it. And you'll notice that half again, since it's a half, that's going to shrink it. It's going to widen that parabola out, and it's going to flip it. Now, the last thing we need to do is figure out these last two. There's my vertex. It's at the top, so that would make it a maximum. And my y-intercept is at 0. I've already done that work, so it'd be at 0, 1. And that is how we graph a quadratic equation in standard form.